Myself, Karanam Rao, Assistant Professor, Vijayanagara College, Hosapete. And today's topic is on Bohr's model of an atom. According to Bohr, Bohr proposed a model of an atom based on quantum theory of radiation as developed by Max Planck and photon model developed by Einstein. Therefore, he has developed his own model based on quantum theory of radiation, and photon model is said to be Bohr's atomic model. Then what is according to Bohr? He has put forwarded all these concepts in the form of postulates. They are said to be postulates of Bohr's theory. Then what are the postulates of Bohr's theory? An atom consisting of a tiny positively charged nucleus in which the entire mass and positive charge is assumed to be concentrated in a small central core called the nucleus, and the electrons are revolving around the nucleus in circular orbits. Then whenever these electrons are revolving in the circular orbits, the necessary centripetal force is offered by electrostatic force of attraction between the electron and the nucleus. Then whenever the electron in an atom revolves only in certain permitted orbits, that means these electrons in an atom are such that they are revolving only in certain permitted orbits, and these orbits are said to be stationary or non-radiating orbits. When the electrons are revolving only in those orbits in which the orbital angular momentum is an integral multiple of h by 2 pi. That means here the orbital angular momentum is given by mvr is equal to nh by 2 pi, where m is mass of the electron, v is the orbital velocity, r is called radius of the permitted orbit. mvr altogether is called as orbital angular momentum, and n is called as principal quantum number, which can take the values 1, 2, 3, etc., and h being the Planck's constant. Therefore, this complete relation, that is mvr is equal to nh by 2 pi, is called as quantization of angular momentum of an electron. An electron is revolving in a permitted orbit does not radiate energy. That means as they do not radiate energy even when they are accelerated, that means the total energy of the system in that particular orbit remains a constant. That means whenever the electron is revolving in a permitted orbit does not radiate energy even when they are accelerated, but the total energy of the system remains constant. When an atom emits an energy in the form of electromagnetic radiation, only when an electron moves from the higher to the lower energy state. That means if I consider the two energy states, if E1 to be the lower energy state and E2 is the higher energy state, when the electron jumps from the higher to the lower energy state, that is E2 to E1, then the energy is being liberated in the form of electromagnetic energy and is given by E2 minus E1 is equal to h nu, where h nu is the amount of energy that is being radiated and is called electromagnetic energy, or nu is equal to E2 minus E1 divided by h and is called as Bohr's frequency condition. This is called Bohr's frequency condition. These are all said to be the postulates of Bohr's theory or Bohr's model of an atom. Now let us find out what is an expression for radius of stationary orbit. Consider an atom of atomic number Z, of nuclear charge Ze, that is of charge plus Ze, that is of nucleus of charge plus Ze. When an electron of mass m and charge minus e is revolving around the nucleus of radius r, where r is the radius of the circular orbit and if V is its linear velocity, then the electrostatic force of attraction between the electron and the nucleus is given by, it is according to the Coulomb's law. According to Coulomb's law, the force F is equal to Q1 Q2 divided by 4 pi epsilon naught R square, where Q1 is nothing but the charge of the nucleus and is given by plus ZE, and Q2 is given by charge of the electron, that is given by E. And when we substitute these values of Q1 and Q2, then this electrostatic force of attraction between the nucleus and an electron is given by F is equal to ZE square divided by 4 pi epsilon naught R square. Then what is the necessary centripetal force? That is, according to the postulates, according to the postulates of Bohr's theory, as the necessary centripetal force is being offered by the electrostatic force of attraction between the electron and the nucleus. The centripetal force is given by mv square divided by r. Therefore, from these two equations, it is very clear that as LHS are equal, RHS must be equal. Therefore, on equating RHS, we have mv square by r is equal to ZE square divided by 4 pi epsilon naught r square. Or, if I cancel one value of r in the denominator, we get one value of r in the denominator on the right hand side, that is to be transferred to the left hand side, that becomes mv square r, that is equal to ZE square by 4 pi epsilon naught. From Bohr's quantization condition, the orbital angular momentum is nh divided by 2 pi, or v is equal to 1 divided by mr into nh divided by 2 pi. And substituting this value of v from equation 4 in equation 3, we have the equation 3 is mv square r is equal to ZE square by 4 pi epsilon naught, at which we have to take the value of v to be 1 by mr into nh by 2 pi. That is, if I substitute, it can be written as v square, that means this complete component whole square, that is given by m into 1 by mr into nh by 2 pi whole square into r, that is equal to ZE square by 4 pi epsilon naught. Or, on simplification, this value of r is equal to n square h square epsilon naught by pi m ZE square. Or in other words, it can be written as epsilon naught n square h square by pi m ZE square, which is an expression for radius of the stationary orbit of an electron. Then from this expression, it is very clear that the radius is directly proportional to n square. That is, if r1, r2, r3 are the radius of the first, second, third, etc. orbits respectively, then according to the radius, then if r1 is the radius, n1 is the orbit. If r2 is the radius, n2 is the orbit. If r3 is the radius, n3 is the orbit. Then they are in the ratio of r1, r2, r3 are in the ratio of n1 square, n2 square, n3 square, etc. If n1 is the first orbit, that is given by 1 square, n2 is the second orbit and is given by 2 square. For the third orbit, it is given by 3 square and so on. That is equal to 1:4:9. In other words, the radius r1, r2, r3 are in the ratio of 1:4:9, etc. From this, it is very clear that electron orbits are not equally spaced. Then what is the radius of the first orbit of hydrogen atom? That means for the first orbit of hydrogen atom, we have to take, for hydrogen atom, atomic number Z is equal to 1. At the same time, this value of R, when we substitute all this value, then that is epsilon naught is equal to 8.854 into 10 raised to minus 12 farads per meter. H being the Planck's constant given by 6.625 into 10 raised to minus 34 joule second, it is not joule per second, it is joule second. And mass is given by 9.1 into 10 raised to minus 31 kg. and E is the charge of the electron 1.6 into 10 raised to minus 19 coulombs, and pi is 3.142. On substitution of all this value, here n is equal to 1 for first orbit. Then substituting all this value, we get R is equal to 0.53 angstrom units. In other words, the radius of the first orbit of hydrogen atom is called Bohr's radius and is given by 0.53 angstrom units or 0.53 into 10 raised to minus 10 meters, which is said to be the radius of the first orbit of hydrogen atom. Thank you.